joining this week's office hours. We really appreciate your time and your feedback. I'm going to go over a couple of announcements and reminders before we go into a couple of updates from the Semantic Kernel team, and then we'll leave it to open Q&A as well if you have any questions. Just want to remind everyone of our cadence. We have our weekly office hours at this time from 8 to 9 a.m. Pacific time every Wednesday to be able to join in and hear what's happening in Semantic Kernel, but also go through any questions you may have. We also have the monthly APAC office hours on the second Wednesday of each month from 4 to 5 p.m. Pacific time as well. And so if you do have colleagues or individuals who are in the APAC time zone, be sure to let them know and be able to capture their feedback. I do want to let individuals know that from the last office hours, they're the same releases. There's some new things that are coming out as well, and there's some new releases we'll have as well shortly. But just want to highlight that if you haven't had a chance to check out .NET 1.22 or Python 1.11, both of those are out, and there are some new changes with OpenAI assistance and others for Python. And so if you haven't had a chance, it'd be great to be able to go and check and see some of the new releases. We also are going through a lot of documentation updates. There's a blog post I'll also highlight on our agent framework documentation update. And so we've been going through some of the different sections and updating as well. And so if you haven't had a chance to read through and learn more, we recommend you do. There's also our new process framework as well. And so have a chance to take a look. I've put the link to the documentation in chat as well. And then, as always, we've put in the link to backlog by bucket. So if you're looking to see what's coming with Semantic Kernel, what we're working on as well, this is a great way to be able to see what's on our roadmap on top of our fall blog that we shared out as well. And then, as I mentioned within blog posts, I have a couple new ones. The announcement for Agent Framework, our documentation updates are out. And so the blog goes through each of the different sections within the framework as well. And then we do have a new update around Microsoft.extensions.ai and some simplifications with .NET partners as well. And so if you haven't had a chance to read about that and learn more, I've linked to our blog as well. And then we do have some hackathon projects internally that we're highlighting that have been using Semantic Kernel that I wanted to share as well. But with that, I'll go ahead and turn it over to Mark to share out. Mark, do you want to share screen or have me go through deck? Let me know what's best.
Actually, we're going to do it in slightly different order. Like Dimitri is going to start off, and then I'll pick up after him.
Perfect. Dimitri, I'll just go to the next slide here for you to kick off.
Yeah, so basically today we are going to talk about our latest functionality for vector stores. And actually, I'm going to share my screen, Sophia, if you don't mind, okay? So I'm going to use our documentation from Microsoft Learn Portal. And today we're going to talk about like, what are our vector store implementations, what are our connectors, and how to work with vector search. So it was to mention that we already released this functionality under Microsoft.semantikkernel.data namespace. So it's already available, but starting from version 1.23 of Semantic Kernel, this functionality will be moved from Microsoft.semantikkernel.abstraction namespace to Microsoft.extensions.vectordata to .abstractions. And the reason for that basically is to allow developers to depend directly on vector data package if the developers are interested only in vector search capability. But all of this documentation was already updated and was published today with the updates for the namespace. And currently, basically, we are working on releasing this Microsoft.extensions.vectordata.abstractions package, and it should be available in upcoming days. So today, I just want to show you like how to work with your data and how to perform vector search on your data. So basically, it all starts from defining your model. And there are a couple of ways. So the first way is basically we call it a declarative way, and because it's possible to define your model with the C# attributes. So for example, here we have a hotel class, and it has some properties like hotel ID, hotel name, description, and so on. It also has a property to store vectors, which is read-only memory float. And then basically what you want to do, you want to annotate your properties with the attributes. And there are a couple of attributes here. So first attribute is vector store record key, which identifies your key in your entity. There is vector store record data, which basically holds some metadata about your entity, like hotel name, description, and so on. And there's also vector store record vector attribute, which basically identifies the property as a vector, which will be possible to perform a search with. So each attribute here has its own set of properties. And for example, if you're talking about key attribute and key property in general, for example, in this code snippet, we use unsigned long as a property type, but as soon as you use it, like, it doesn't mean that it's going to be supported by all connectors. So we have documentation for each available connector. We already have several of them, and there are more connectors coming. But in order to understand, like, okay, if I want to use a key in my entity, what type I can use, you need to go to specific documentation for each connector. And each connector has this table, which basically specifies the supported property types for each entity property. So basically, as we can see here, Quadrant supports unsigned long and GUID properties. For keys and for data, there's this set of properties, and for vector, there's only read-only memory float. And then for each connector, there's similar information there. So regarding vector store record data property, basically there are several attributes, like is filterable, is full text searchable. Basically, those properties allows you to create a collection in your database of choice, and basically create indexes based on your preferences. For example, if you want to perform your queries and be able to filter by hotel name property, you can set this property as is filterable, which means that as soon as you will create a collection with our abstraction, the index in your database of choice will be automatically created in order to make this property as filterable. In terms of vector properties, there are also a couple of different parameters here, like dimensions. You can specify the dimension of the vector you want to store. Index kind and distance function, those are properties related to the configuration of your vectors, basically. And again, each connector supports different set of index kind and distance functions. So in order to understand what parameters are supported for a specific connector, you can open documentation for a specific connector and find the information about index kinds and distance functions available in this connector. So this is kind of like the declarative way how to define your models, but there is also another way, which is called like imperative way. So for example, in case you don't have an access to your class in order to decorate it with attributes, you actually can define a vector store record definition object, and it has very similar properties. Basically, vector store record key property, and here you need to specify the name of your property and the type here. There's also vector store record data property, similar to the attribute, where you specify the property name and then type, and also the same set of parameters like is filterable or is full text searchable. And there's also vector property. Again, you specify name, type, and then the similar set of parameters as we already saw in attributes. So this is how you can define your model. And now, as soon as you define it, you can start upsorting it to your database, getting it by ID, or perform a vector search. So, for example, in order to start working with it, basically you need to first of all you need to choose what kind of connector you want to use in your application. And in this case, as an example, we want to take a Quadrant. So we install our quadrant connector, and then we initialize our quadrant vector store. So vector store is basically an object which will allow you to get your collection, and collection is another type of object I'm going to talk about later. And it also allows you to get a list of available collections from your database. And then as soon as you initialize vector store, you can get your collection. So collection is basically the collection from your database, or if you're talking about relational database, it's a table, right? And here, in order to get a collection, you need to specify a key you want to work with, a key of your entity, and then the entity itself. For example, here it's hotel, and then as a parameter, you want to pass collection name. So as soon as you initialize this collection instance, you can start working with your defined model. So first of all, you need to ensure that your collection exists in a database, and if not, you want to create it. So we can do that. And as soon as this step is performed, during the collection creation, basically, our abstractions, they are going to check all of these properties I showed before, like if is property filterable or is it full text searchable. And based on this information, and also based on vector information you provided, like vector dimensions, index kind, distance functions, we're going to use all of this information to create a proper schema in your database using all of this data. It also includes like property names, property types, and so on. So as soon as the collection is created, you can define your model, and you can initialize it basically with all of the properties. Like in this example, we are initializing model, and then we can absort it in our collection. So as soon as it's absorted, and absort here means that we will insert it in case it doesn't exist, or we will basically update it if it already exists. As soon as it already exists in a database, we can then get it by ID, for example, and we can work with it in our code base. Now, in terms of like retrieval, we can get a record by ID, but we can also perform a vector search with it. So here's an example how we can do that. So for example, we have this input, like I'm looking for a hotel where customer happiness is the priority, which we want to generate an embeddings from this string. So basically a vector. And then we want to use vectorized search async method on this collection instance to perform a vector search. There are also a set of parameters I'm going to talk about later. But then as soon as we have this result, search result, we can get a hotel instance from it. Or we can also, on top of that, we can also get a score, basically, which will identify how similar this record is comparing to the previous input. So I want to talk a little bit more about vectorized search because like it also contains a different set of parameters. So basically, first parameter is vector property name. So for example, as you can see here, we can have a model which may have like multiple vector properties. So for example, here we have a product model, and it has like description embedding and feature list embedding. Now, if you don't specify what vector property you want to use in order to perform your vector search, we are going to use the first one defined in your model. But for example, if you want to use a custom one, you can define your vector search options instance, and you can specify that your vector property name should be this feature list embedding, which will mean that as soon as we will perform a vector search, this specific property will be used. Otherwise, by default, the first one will be used. So this is the first parameter. The second parameter is top and skip. So basically, those kind of parameters, they allow you to implement pagination in your applications in case you want to skip some records returned from your vector search, and you want to limit your result set to a specific number of records. So you can use top and skip parameters for that. There's also include vectors parameter, And by the way, it's worth to mention that this parameter also exists in get by ID records. So, and by default, it is false. So basically, this parameter allows you to include vectors in your result object, because basically, if it's false, which is like the default value, it can significantly reduce the amount of data retrieved from the vector store, making searches more efficient, because like vectors, they contain some specific size, and maybe in some cases you don't need it. So if you need it, you can specify this property as true, which means that as soon as you will get your records from the vector store, those records will include those records will include vectors as well, or embeddings. So this is include vectors property, and then we also have vector search filter. So if you remember, we were talking about this is filterable property parameter on properties, and basically this vector search filter parameter, it allows you to perform a little bit more detailed vector search. So on top of your vector search, you can also like define a filter, which basically will make your vector search a little bit more specific. For example, I want to search using this vector, but I also want to, I have this model glossary, which has properties like category, for example, and also text, which is an array. So I want to use vector search, but I also want to limit my result set, and I want to find all the records where my category is external definitions, and I also my text array should contain this memory record. So you define this filter, you pass it to vector search options, and then you pass this vector search options to vectorized search methods. And as soon as you've done it, basically your result set will be limited based on the filtering you specified. As for now, there's only like two types of filter clauses. The first one is equal to, basically means that you can select your property, and then this property should be exactly the value you specified. And then there's another type of filter clause, which is any tag equal to, which means that as soon as your property is an array, like here in this example, we have a list of strings tags, right? So if it's array, you can specify it, and this array should contain the value you provided. But it's worth to mention that this filters clause set will increase. So basically, we're going to add more filters in the future. But as for now, like only these two filter clauses are accepted. And on top of that, I just want to mention that we updated our documentation for memory stores with all of this functionality, and basically, we have this information about our supported connectors. So I highly encourage you to check it. Leave your feedback about the functionality, about the documentation itself. It will be very useful for us. And we also added this page about legacy semantic kernel memory stores, because currently there are also like a previous version of our memory implementation, and this page contains all of the information about the difference between old implementation and new implementation, and the available list of connectors for the old implementation. And also later today, Wesley is going to show us how to work with these abstractions and how to work with multiple connectors at the same time during the little demonstration. That's it from me for today. Thank you very much.
Dmitry, one question for you. Great job. When can people start to use what you showed today?
That's a great question, Evan. So as I already mentioned, this functionality is already released under Semantic Kernel namespace. So you can go ahead and try it. But as I already mentioned, from version 1.23 of Semantic Kernel, this functionality will be moved from Microsoft.semantikkernel.abstraction namespace to Microsoft.extensions to vector data, Microsoft.extensions vector data.abstractions namespace, which means that if in case you already use this new implementation, new abstractions under this namespace, and so as soon as you update our package versions, you will have to basically update the namespace in your code. Otherwise, if you want to wait until Microsoft.extensions vector data abstractions will be published, you can go ahead directly in our repo. You can run samples from our repository, or you can clone our repository and then reference those packages directly from your application, start playing with it, and then as soon as it's available in Nugget, which will be available in the next couple of days, you will be able to download it directly from Nugget.
Perfect, thank you.
Great, Dimitri. Any questions folks have before we move on? I see a good one in chat from Matt. Is hybrid search for AI search supported with this, or is it limited to vector-only search?
As for now, it is limited to vector-only search, but we do have plans to extend it to support hybrid search as well. And as far as I know, it's going to come up with the new set of interfaces, which will also support like a hybrid search, full text search, and so on.
Perfect. Thanks so much for the question, Matt. Any other questions before we move on to a couple more demos and pieces before open Q&A? If not, we'll move on to our next speaker, and feel free to put any questions you have on this or other topics as well in chat as we're going through. Oh, Mark, it looks like you're on mute.
Okay, sorry about that. Yeah. Okay, yeah, so let me share my screen, right? So yeah, I'm going to start with the documentation as well, right? So we've introduced a new feature called text search. This is a layer above what Dimitri has shown. So it's a set of abstractions for performing text search, and you can use it for web-based search or searching in vector databases, or you could do your own implementation and have your own, if you've got your own search service that you want to integrate with Semantic Kernel. So this is another preview feature. It'll be available in the next set of packages that we release in the next day or two. But the documentation is published, and if you clone our repository, you'll be able to kind of get access to the code and to all the samples that I'm going to show today, right? So this is principally used for RAG-based applications or function calling where you want to integrate with a search service, and you can build on top of web search, which you can also build on top of vector databases. So there's a set of documentation that talks about the abstractions, talks about how you create plugins for text search, how you implement function calling, and then how you build on top of all the vector stores that we support. So I'm just going to go through a couple of different samples. We have a getting started with text search project. So if you want to get familiar with all the concepts that are involved, you can basically just go through each of these samples. There's only 4 steps with a couple of samples in them. This first one is like the hello world of text search. In this case, we're using Bing as the underlying search service. So I can instantiate my Bing text search. And then for the rest of the code, all I know is I have an implementation of iText search. So I can perform a search and get search results. I can get my search results back as strings. So when I run this particular example, you see I'm getting string search results back. And these represent the snippet of text for that page that Bing has returned. We can also, I could just as easily kind of like call Google. So I just instantiate a different text search. The rest of the code remains the same. We allow you to access whatever the underlying objects are that the search service returns. So for Bing, it would be Bing web pages, and then Google, you get these results. So I can get access to the full data. We also allow you to get access to a normalized form of a search result. So the normalized form has a name, a value, and a link. So if you want your code to be abstracted away from the details of the search service that it's using, you can use this result format. So if I want to do RAG using the new text search service, it's fairly straightforward. So I'm instantiating a kernel with an OpenAI chat completion. I'm going to use this sample can switch between Bing or Google, either of them will work. So once I have my text search instance, I can create a plugin from that. The plugin that I've just created will have one function, which is a search function. So I can add that plugin to the kernel. Once I've added the plugin to the kernel, I can then kind of call it from within prompts, right? So here, what I'm doing is I've got a query, which is what is semantic kernel. I've got I want to use grounding data that comes from a web search. So I call the search plugin with my query, and that will retrieve some grounding information. And then the model will use that grounding information to respond to the query. So very, very simple RAG. That's very straightforward to do. If I want to include citations in the response, basically, so I can provide the source of the data. It looks very similar. There's a couple of changes here. One, when I'm creating my plugin, I'm going to create a plugin with a function called get search results. This returns the normalized version of the search results. And I'm going to use a handlebars template. In my handlebars template, I'm going to call the plugin. I'm going to then output the name, the value, and the link for this from the search results. And then in my prompt, I'm going to say include citations to the relevant information. And then if we look at the response in this case, you can see we get citations and a link to where that information comes from. We can also do things like apply a filter. So Dimitro talked a little bit about filtering. Filtering is applicable here. If I only want search results to come back from one specific site. So in this case, I'm creating a search filter. The site is devblogs.microsoft.com. And in this case, that's where all the citations come from. So I only pull information from that particular site. And let me jump on to a kind of like, function calling example. So for basic function calling, again, because we've created a plugin from our text search service, we've added that plugin to the kernel. We can advertise this plugin to the model, and the model can call it. So in this case, what I've done is I've enabled automatic function calling. And now when I invoke my prompt, I don't need to inject the context into the prompt. Then what the model will do is when it gets this request, it will call the plugin, and then I'll get the results back that way. And I can do things like if I want, like in my prompt, I can customize the functions for the search plugin. And in this case, I'm going to create a customized function which has an additional property which allows the site to be specified. So I'm creating, if you look at this example, you'll see it creates a customized function. So now in my prompt, what I can say is, what is the semantic kernel? And in my prompt, I can say only include results from this particular site. And then when the model calls the search plugin, it will pass the site information, and the information will get filtered to just that site. So the last sample I want to just show very quickly is we can do all of this on top of vector stores then as well. So if we look at the basic RAG example, in this case, what I'm doing is I'm creating a vector store record collection, which points at a set of records within a vector database. Once I have that, I can basically wrap it in a vector store text search. And this allows me then to just treat that as any other text search implementation, right? So from here on out, once I've got a text search instance, I can convert it into a plugin. All the rest of the code is exactly the same. So I can switch between using web search or using any vector database and perform text search, perform RAG operations, perform function calling, and my code remains exactly the same. So we get that isolation from the underlying vector database. And if I want, I can register multiple plugins for multiple different record collections. So if I had one record collection that contained, say, hotel information, and another that contained restaurant information, I could register both of those at the same time and perform different types of searches depending on the prompt that the user had entered. Okay, so okay, so I'm going to stop there and just yeah, allow kind of like Wesley's got a nice demo that kind of brings everything together.
Great. While you're transitioning, Mark, there's a question in chat from Chris. Is there sample code internally for Microsoft employees to use in internal Teams channels or areas where training videos are stored to use those as part of the data pulled back for troubleshooting scenarios?
First,
I think maybe the sample that I'm going to show could be something like this. Maybe Chris, have a look
Yeah.
at what I demo and then let us know if this is, if you're looking for something different.
thanks, Wesley.
Sure. So I'm just going to share my screen there. I just put on the chat a link to this, to the location of this demo application, which you can download and check out. It has a nice README there, which explains all of the settings that you need to set to make it work and other options that you can use. And ultimately, what this sample does, let me just zoom in a little bit here so that it's a little bit more readable. What the sample does is it allows you to take a PDF file. It chunks the PDF file into sections. It generates an embedding for each of those sections, uploads each of them as a record to a vector store, and then allows you to interrogate that document by using a chat experience with RAG input into that chat experience. It's most of the code in here is actually about hooking up all of the different vector stores and all of the different AI experiences that you can use or sources, because we've built the example so that you can use Azure OpenAI or Azure OpenAI embeddings, OpenAI embeddings. I might add a few more as well, just to make it a little bit richer, maybe local ones, and then you can pick from various vector stores. Weaviate, Redis, Quadrant, etc. We also, you know, there's also an in-memory one that you can use as an option. So I'll maybe start with that in a sec once I run it. But first thing is I just want to run through the code a little bit and explain a little more about it. So this is the application is essentially a hosted service application. .NET hosted service. So the RAG chat service class here is the main hosted service that orchestrates everything. It has a dependency on this data loader class for loading the PDF file into the vector store. There's the program file that essentially just bootstraps everything, does all the registrations, and sets up the hosted application. And there is this text snippet model, which is our data model. And as Dimitro was demonstrating earlier, this is annotated with our attributes to explain what kind of what these properties mean. So we just have a key, we have some text, we have a description, a link, and the embedding for the text. And you'll notice that this text snippet is actually it's actually generic because we support multiple databases. So some of them might require us to have a ulong, some of them might require us to have a GUID, some might require a string, and all of that is set up in program. The rest of the code is completely agnostic to that and just is generic to allow any type of key. Let me dig into the data loader very quickly. There's a little function here that uses PDFbig to just open the PDF file, get the pages, get some word blocks, and segment it into sections, and then that's used here at the top. Actually, as well, this code is just using the vector store record collection, which is the collection that Dimitro was referring to. We call create collection if not exists as well. We load the paragraphs, we break them up into chunks, and each of those we break them up into batches, sorry. And each of those batches, we generate the embeddings for that section, and then we upsert those in a batch. And there's some code here to just retry as well for the embedding generations, that if we get throttled, we just retry. Other than that, that's really all that's there. It's not super complex. Here's the upsert batch. Here's the generate embeddings. This is where we build our text snippet from the paragraph text, where we generate the embedding from the paragraph text. So if we look at the React chat service, as I mentioned, it's a hosted service, so it implements this interface with start async and stop async, which is pretty much just boilerplate code. But on start, we start loading the data, and if we look at what that looks like, it's just calling into the data loader, which is passed in as a parameter at the top here. We basically give it the PDFs that we want to load and some configuration settings around batch size and how long to delay, so that we don't get throttled. Then once this is loaded, we start this chat loop, and this essentially just waits a little bit to make sure that the data is loaded. And once it's done, it starts. It grabs the it basically grabs the semantic kernel that was passed into it and adds a plugin for vector search. Now I'll talk a little bit more about how this is hooked up in a sec, but this is essentially similar to what Mark was describing earlier. Actually, I'll talk about it now. There is the vector search. There's the vector store record collection that is wrapped by a text search implementation specific to vector stores. And it's just basically saying, well, we want to take the output from the vector store and turn it into the standard, or make it available to Semantic Kernel via the standard text search interface. And then we can wrap that in a plugin that we add to the kernel. And then here's the actual chat loop, the while loop, where the assistant asks, hey, what would you like to know from the PDFs? And we have some code here to allow you to exit out of the application. Here we're doing the invoke prompt, similar to what Mark was showing earlier, where we're basically invoking the search plugin and outputting the results. We're saying, hey, include citations. We're including the question. And then we've got some code here to stream the result message from the LLM out to the user. Then in the program.cs file, there's not a huge amount of here. We're creating the host application builder. We're configuring we're setting up our config, creating a app shutdown token, cancellation token and source, adding our kernel to the host application builder, and then we're just registering, hey, do you want to use Azure OpenAI? Well, register that, or if you want to use OpenAI, use that, register that. Same with embeddings, and then switching through the different vector stores and registering the correct one that you asked for. And then down here is just some general purpose registrations as well. As I mentioned, we're basically wrapping the vector store registration in a vector store text search, which then gets converted into a plugin. And we're adding things like something to generate a key, you generate a GUID key or a string key, we register the data loader, and we register the hosted chat service, React chat service. And that's pretty much all the code. next up, I'm going to just run this. Actually, before I run it, I want to just mention as well, what we've done here is you can see here in the Learn site, there's a download PDF button here that you can use to download a PDF of all of this documentation. It ends up looking like this once you do it. And that's actually the input that I'm going to use here. So I've configured this to use that. And that's just upserting the records and doing the embedding now. And in this case, I'm using the in-memory vector store. So as soon as I shut down the application, it's all going to be gone again. But yeah, now I can ask it questions about this documentation. So for example, how do I annotate a data model when using vector stores? And there we go. We get an answer telling us, hey, you can use vector store record key, and it shows us a nice example of how an hotel class would look like with these annotations, plus citation here, plus the citation here about where in that source document PDF the information was found. So it came from page 101. And if we go to page 101, we should be able to see, there it is. There's the information that it used to find it. So yeah, any questions?
Not seeing any in chat. Chris, the question you had earlier on the sample code, does this help answer that?
I'm not. I don't think so, but I'm not sure. This is my first meeting, and I'm working on a project with our PG, and been away from it for about 3 months, and I'm coming back, and I just saw this, and it was kind of interesting. Like we have like a Teams SME channels like on our Azure products, and people go in there and ask questions. And it would be nice to be able to have something that can go out there when on our AI asks questions to go out there and include like searches to go to Teams and filter through those conversations. We also have like new product features that get videos and training, and it gets put on, like internal place where like the videos get stored, I guess, much like the recordings of these teams. And the only ask is if anybody's like has a sample to where they've worked through like all the permissions and everything needed in the code that would be able to go out there and include that as part of a search.
So I don't think we have an example exactly like that, but ultimately you should be able to use a similar approach, at least for providing for building a chat experience that includes that information. The main difference would be, instead of loading the data from a PDF like we are doing here, you would, as you kind of probably guessed, you would need to go out to the different sources,
Yes.
grab that data, chunk it up, and import it into a vector store as well. But yeah, I'm not aware of something that,
Well,
at least I don't think we have anything that goes out to all these different sources at the moment.
Well, yeah, you can use logic apps with semantic kernels. That's probably a good way to start, because you can use logic apps with the Teams connector, put in the IDs of each one of those chats, and then every time a new chat comes in, you can run it through this, embed it, and then be able to answer questions.
okay, I was looking at it more instead of having to index this in another place of like you were showing Google search, right? And I was just in my thought was like, oh, okay, cool. So if we can go ahead and do that and just go out and search, because you can go into Teams right now and go to that SME channel, right? And you can search, you can put an error message in there and it'll search and it'll give you anything in matches on it. And I was thinking it would be that simple and not have to index all that information repeatedly over and over, because some of it can be out of date and you got to worry about freshness and all these things. So that was just the ask.
Yeah, I mean, you certainly don't have to do embeddings. It's just going to make it exponentially faster rather than crawling, again, doing that search in Teams, pulling that information back. So I'll paste in, I put the Logic Apps blog, I'll paste in a link to the Teams connector. You can maybe just give that a shot and see what you think.
Okay. Can I
Yeah,
ask
thanks,
another
Chris. Feel
question?
free to reach out to us too, as you're going through. But you said you had another question as well. I'd love to hear from you.
Yeah, and it's probably not the right for this, but like I said, I've been in this, and I actually work with, I think, Chris on here. I looked at this, but we finally upgraded like this semantic kernel from whatever, I don't even know what we was. It was old, and we went to 1.23, and then we had to update the OpenAI, and it's broke a lot of stuff. And I'm trying to go through like the documentation and figure out what's replaced what. Is there is there anything better internally than what's online, or on how to fix like all this the things that got broke and the changes between the new OpenAI SDK and its semantic kernel?
Are you using the documentation we have? We have a whole site, a page that goes step by step of almost find and replace of what you need to change. Have you tried that one?
I
The
found a blog.
migrating?
I found a blog post, and what we had as an issue with semantic kernel, it was doing a lot of stuff behind the scenes. So we had to, I worked with somebody, and I can't remember his name, to figure out how to go out and do some of the stuff manually, and then we make our own calls to AI search and via plugins and things like that. And I'm using like a chat completions function tool call of a type to get back and things like that. I don't know if I found it. I just found a blog out there, and then I'm trying to read through what's out there, and I didn't know if there was something internal is all there. If there's not, I'll keep trying to go through that.
Yeah,
My
just put
problem
a
is I
link
only
in
get,
the
yeah, my
chat.
problem is I get like 30 minutes here or there to work on this stuff because I have to take cases, and it's like by the time I get into something, it's already time to go do something else. So it's like I'm just trying to save myself some time. But I'll
Gotcha.
check
Yeah,
that out. Thank you.
no problem.
Great. I see some other questions in chat. Matt, that was a great question. Mark, I saw your response. Is there anything else you want to highlight, Mark, as well for the recording?
No, just to kind of emphasize, yeah, iText search just gives you, if you implement that yourself, then you get integration with the rest of Semantic Kernel, like creating plugins, all of that sort of stuff for free.
Perfect. Thank you so much. And then Joshua, I'd love to hear your question on agents and agent group chat. If you want to come off of mute, we'd love to hear from you.
Yep. You hear me?
Yeah, we can.
Okay. So we're working with the agents and the agent group chats so that we input something like a JSON or whatever else, and we obtain an output which is worked by the agents taking turns. We use their samples, but the question is how we can define when we got a final answer from the agent group chat, because as of now we took a look at some samples, and it's just an exchange of conversation between agents, and then you get a stream of responses between them, and there's no clear way to understand which one is in the list of the responses the final answer of the conversation. So the techniques are for now like putting some textual markers on what you believe is the final answer, maybe putting a reviewer agent that says, okay, this is the final answer. I put this text. So you can just put a termination strategy that checks if the string contains this marker that say, okay, I finished, and this is the end of the conversation. Moreover, there is also a problem in which whenever you ask to agents to work with code or JSON or something else, they tend to put code markers like ticks and JSON markers, and there is no way to remove them. I'd like to know if it's supposed to act like this or not. On this note, I saw that there is a pull request for Autogen that basically kind of talk about this. I'm trying to send, but it's stuck. Give a minute. And
Perfect. Chris,
I would like
oh,
to
go
know if
for it.
the solution is Autogen or if we can do this with semantic kernel only.
Yeah, Chris or Evan, do you want to talk about group chat?
Yeah, thanks, Joshua. Chris here. The in terms of the code markers. I think that's can be a model, something the model does automatically. I'd be
As of now, we just put a semantic native function that just clears the output from the markers and all the
yes.
dirty text. That's for what we do for now.
Yep. The so I'm glancing at your the PR you link. Thanks for that. The in terms of the termination criteria, I'm wondering. I mean, that can be very contextual, of course, to any particular agent flow.
Yes, of course, it's a wide topic as the context can be wide, but in terms of termination strategy, in this case, the usual termination strategy is searching for something in a string. If it's found, then it terminates the loop of agents conversation. Then usually this consider the things closed, but there is a lot of conversation that it gets added as a response while you string the loop of agents responses. And sometimes the reviewer in the termination strategy is the last one. Sometimes it's in the middle, and other agents have spoke later or earlier, and you can really get where the termination strategy kicked in, and you finish the conversation and you get a final answer.
Yep. I do wonder if some type of summarization, if you're hitting the termination criteria, if then there's a need to then summarize what's occurred as kind of a type of carryover. If what I hear correctly is if you're needing to kind of capture information in more than just the final message, then
if this can make it easier for you and I can narrow down the context, I just putting in a JSON and I need it to produce a JSON schema. And I have an agent that it's told to produce JSON schemas and an agent that is told to be an overviewer and check against the JSON schema rules if the JSON schema produces is valid or not. When it finds that it's valid, then it adds a marker, a text strings like valid answer, for example, and the termination strategy just checks if that is in the content of the strings and that it's considered terminated. And that,
I see.
but the answer is sometimes up, down in the list of the conversation. There is no way to tell when the termination strategy kicked in and if the last message is always the final answer or some agents told the response before or later. It's quite confusing. I have to scan through the results and see by hand, by eye, if the response is valid or not, if it's the final answer.
Is what you're describing is that your goal is to ultimately extract that JSON response?
Yes, to actually create some kind of strategy to say this is the final answer, this is what you were looking for, here's the answer.
I hear you. I understand. That's a good scenario. I've taken some notes on this. Maybe I can follow up offline. I think I'm going to consider. This is a great requirement, great scenario. I'm glad you identified this. Let me consider what you're presenting, and then we can get back and determine on the best approach. And I think this would be a good pattern to ultimately support.
Okay,
Perfect. Thanks, Joshua, for the question. Yeah, we'll definitely get back
thank
to
you.
you and be able to circle back as well. I see in chat there was a good question around re-ranking with Jason Wesley. Anything either of you want to elaborate or add on, or has that one been wrapped up?
I think that pretty much answers my question. I was looking at a Cohere solution for some. So I was working with the new Azure SQL connector and semantic memory this weekend, and I've got a hybrid search working on it, but I'm running into the re-ranking issue where I want the results ranked semantically, whether they were an exact match or just high in the relevance match. But okay, never mind. Never mind. I'm going on. He answered my question. Thank you.
So yeah, it'll be interesting to know, Jason, if there's like, is there a bunch of tweaks that you can pass to the ranker that you would like to be able to do, which will help to improve the ranking capabilities? And you know, we kind of, I suppose it's tricky to represent some of those sometimes during the in the abstraction, because the abstraction has to work across a lot of different databases. But in some cases, we may be able to say, well, let's move some of these to the constructors and have a separate hybrid search implementation per database. You know, that implements the interface, and you can construct it on its own and pass in a whole bunch of parameters that tweak how that instance works. And those parameters will be specific to that vector database type. But yeah, if there's anything like that you're kind of keen to say, okay, well, I really need this type of tweaking capability, do let us know, and maybe put it on the chat or create an issue on the Semantic Kernel GitHub that explains kind of what your needs are, and you know, we can incorporate that into our design.
Sure. Thank you. I'll play around with the re-rankers and see how or if it even helps me. Thank you.
Sure. Yeah, no problem.
Perfect. Thanks for the question, Jason. Yeah, do follow up if you do have any further questions as well. With that, it looks like we have no other questions in chat, and we're at the end of time as well. I just want to thank everyone for joining today's office hours and everyone from the Semantic Kernel team presenting out. We'll meet again next week, but in the interim, if you do have questions, feel free to use the GitHub discussions as we go through and triage that on a daily basis as well. Thanks, everyone.
Thank you.
Thank you.